Okay, welcome everyone. This is the Boston.NET Architecture Group. My name is Robert Hurlbut, and tonight we're going to be looking at an interesting framework, an interesting SDK, something new that I'm going to learn about as well, Temporal.NET. And we have Chad Retz, who's going to be speaking to us. He's coming all the way from Dallas, Fort Worth. And so thankful to Chad, and then also Ryan worked together that help us put this together for tonight. So really welcome both to join us and to present on this very interesting topic. So thank you. I'll turn it over to you, Chad.
Sure. Hello, everybody. My name is Chad. I work over here at Temporal. And I think what we're going to do today is, we built this .NET SDK that is now in beta, but it's going to go to GA not too long. And I'm going to spend a little bit of time describing what Temporal is. Now, we have a whole DevRel section of people that could probably do a better job than me, but I can at least describe it from an engineer perspective. And especially if you're familiar with Azure durable functions, or maybe even Orleans journal grains, it'll be somewhat familiar. And then after I've described Temporal a little bit, I'll describe how it looks in .NET, because that's one of the interesting challenges of our SDKs is to make everything look as language native as possible. And for C#, that's awesome, much more awesome than you can imagine in other languages. And then I'll explain some of the interesting things I had to fight through and go through to get the SDK to do exactly what we wanted. And then we'll have plenty of time for questions. So without more. So like I said, this is basically what we'll talk about. I'll explain Temporal, then I'll explain Temporal.NET. I'll go over all the challenges and then Q&A. So first of all, and feel free to add questions in the chat or save them to the end. Doesn't matter to me either way. So first of all, what is Temporal? And like I said, we have a DevRel arm and we have a whole website that explains this better, but I'll do my best pitch here. So Temporal is a very open source, like MIT licensed open source durable execution framework. So what does that mean? That basically means we provide a way for you to write code in your favorite language, C#, for instance, and it's guaranteed to complete, and it's guaranteed not to crash. Now, I know that if I throw around the word guarantee, that can kind of send some alarm bells, but it's true, and I'll explain how it works here in just a little bit. So the history of the company is basically the co-founders were working at Uber on a similar product called Cadence, and they brought that over, forked it, and made Temporal out of it. But they have been building things like this for a long time. Amazon SWF was by one of the co-founders. Azure Durable Task Framework was by another one of the co-founders. One of the leads of Orleans back in the day also works with us. So a few years back, they created Temporal, which is basically forked off of Cadence. And so what Temporal is it's like an event source system to allow guaranteed execution. So you have other it's a workflow engine, but it's a powerful workflow engine that allows you to define your workflows in code. And it guarantees durability and crash proof by using event sourcing and replays and deterministic workflow execution to guarantee you can resume at any time. So it's very normal to, do a sleep for months in a workflow, or have some loop that runs for weeks. It doesn't matter. It's all durable and guaranteed. So what makes up Temporal is you have a few components. You have the server, and the server is essentially a glorified database, an event store that is also task distribution. So it also gives events and receives commands from the actual workers where your code runs. A workflow is, as you might expect in another workflow engine, a series of steps that is defined in your language of choice. And this isn't just trivial steps. Throw for loops in there, start .NET tasks, sleep, invoke other methods, anything you want. We don't really care so long as it's deterministic. An activity is when you need to leave the deterministic world. So a workflow can invoke an activity, and an activity is just an arbitrary C# method that can do anything. And so workflow invokes that, serializes the arguments, and then wherever the activity worker is, will invoke the activity. And like I said, the activity is basically anything you want. Make an HTTP call, doesn't matter, doesn't have to be deterministic. And so the SDK is the toolkit that lets you build these workflows and activities, and it has a smart type safe client, among other things. So it's much more than a SDK is much more than a smart client. It actually runs your code. The temporal server does not run your code. You run your code. The temporal server just orchestrates tasks between your code. So a quick overview of the server. It's an MIT licensed server built in Go. You have multiple choices of database vendors. It orchestrates the tasks to workflows. We do have a full UI that lets you see all the state of all of your workflows at any time. You can even like view the stack trace of where the workflow is paused, even when it's not running. And then we have Temporal Cloud, which is us hosting our own server. And we do a good job at reliability to the point to where most of our users are cloud users these days. And it's very easy adoption as opposed to setting up your own cluster. But we're committed to open source. It's MIT licensed. Run it yourself if you'd like. A lot of users do use the local dev server. We even have hooks into C# that'll download it and run it as a separate sub process. So inside your integration test, for instance. So what is the SDK? The SDK includes the API for writing workflows and activities. So this includes things like sleep and task management, .NET task management, determinism wrappers, and then it has the API also to write activities, which are those general purpose, do whatever you want things. It also has the code to run them. So it has a worker daemon, and the worker daemon that receives tasks from the server and then invokes your workflow. They're very parallelizable, so running hundreds of workers, each worker running thousands of workflows, no big deal. And the server and the workers together for many big companies will run millions in a second or two. No big deal. So we have SDKs for Go, Java, TypeScript, Python, and .NET. The Go and Java ones were forked alongside of the Uber Cadence project when Temporal was started. However, TypeScript, Python, and .NET leverage a common Rust core. These SDKs are complex beasts that have many state machines within them and many things to get right. And it's unreasonable for us to rebuild that in every language. So we wrote a common Rust core and we invoke it via TypeScript, Python, .NET. And I'll get into how we do it in .NET here in a little bit. So what is Temporal.NET specifically? It is the SDK to do everything in C# with Temporal. So it's currently in beta, but there's a lot of large customers using it. About a month ago, we had our own user conference called Replay, our second annual one. And even the current chief architect for Microsoft at Azure Durable Functions is running Temporal workflows these days and has a presentation you can go see. So it's a high level client. It also has a deterministic task scheduler, and it communicates back and forth via that Rust core. While we technically support really old .NET framework, we still have all the new features, and some of them have compiler conditionals. But there are some cases where we even use like async iterators and stuff. We have extensions to support DI, generic and ASP.NET hosts, OpenTelemetry, and pieces like that. And since it's in pre-release, you have to add pre-release to your NuGet adding, but that's how you would add it to your project. And for those of y'all that are not just .NETers, but use other languages, a lot of what I'm saying here actually applies to many other languages. So it's definitely worth reading about and understanding. And basically, once you write your first workflow and you realize like it's guaranteed to complete no matter where it runs, it'll change how you write processes. You're no longer going to play with tasks with message queues and databases in a lot of cases. So here's how it looks in C#. So first of all, I mentioned there's this concept of an activity. An activity is an arbitrary method that you can do whatever you'd like in it. Here's a case of an activity that makes an HTTP call called do purchase. And you see, I just add the attribute activity above do purchase. And the input and output does have to be serializable. We use system text JSON by default, but the conversion is completely customizable. You should heartbeat. We provide a keep alive mechanism called heartbeating on long running activities, but short running activities don't need it. They're retried by default, and you should make them idempotent, but they're completely retried by default. All of the retry policy is customizable, and it comes with a cancellation token that's server backed. So that cancellation token will get canceled when it needs to. So as you can see here, it just makes a HTTP post. And I chose to just show how you could throw a non-retriable error on 400s as opposed to letting the default be a retriable error. But there are a lot of other things that that make up activities that are in the documentation. But this is basically how it works in a nutshell. Nothing too special. Now, defining a workflow. This is where it gets special. So a workflow has to be deterministic. And the reason it has to be deterministic is because it's long running and may resume anywhere. So you may think, well, how do you keep a local variable like current purchase here resumable on another machine? Maybe do you serialize the stack? No. So we use event sourcing. So basically, when you reach any point like this workflow delay async here, and I'll explain later why it's not task.delay. That's a durable timer. That's a durable sleep. So that may wake up on a completely different machine. So what essentially happens is we keep all the steps, and then we will rerun this same code with the memoized pieces for maybe activities that have already completed or timers that have completed, or continue on from where it previously left off. And I can explain some of the event sourcing concepts, but if you're familiar with Azure durable functions and things like that, it'll make sense to you. So you can see here, we essentially sleep for 10. So this is like a one-click buy workflow. It's just a made-up hypothetical for example purposes. But you can see here that we sleep for 10 seconds. That's, of course, a durable sleep. A process crash will not mess with this. There's no, it will be woken at 10 seconds if there is a worker somewhere ready to execute this code. And then we actually will catch the possibility of a workflow cancel server side that is reported as .NET task cancellation, and we'll set the purchase as canceled. Otherwise, if it passes 10 seconds, we'll say, okay, you didn't want to update your purchase. It's confirmed. Go ahead and do the purchase. And we also show here a couple of interaction points. So you'll see that the workflow class is annotated or attributed with workflow, and the main workflow run function is attributed there too. But you'll see that a workflow signal, which is a unidirectional workflow interaction, is attributed with workflow signal. And the workflow query is a read-only call out, and it's attributed with workflow query. So that's how you can interact with the workflow from a client. We also have workflow update, not shown here. It's still in its early stages, but that's the basic idea. And it's all single-threaded, so you don't have to even worry about mutexes or anything, because this runs deterministically. Even if you did like a task factory start new, it would run those coroutines deterministically, because these awaits are powered by a deterministic task scheduler we wrote. So here's how you would run a worker. Worker is what runs the workflows and activities. This is just like a snippet from what might be like a program.cs or something like that. And you just instantiate the worker and just call execute. I used a cancellation token that caught key press here just for a good Control-C capturing, but it's really straightforward. So we instantiated the activity because it actually has state, it has an HTTP client, but otherwise you just add the activities and workflows to your worker that you need to run and run it. It's that simple. And you can have hundreds of those workers. It's no big deal. We have extensions to support DI and generic host support, so it really just falls right in if you want to. And then you have executing the workflow. So executing the workflow is this is just the smart client side of it. You don't even have to have it, and most people don't have it on the same process where the worker's actually executing the workflow. This is just the client, but it's a type safe client. So you'll see that you connect it, obviously connect to the server, but you see that start workflow async call there. That's using a Lambda expression you might have seen, like I think Hangfire and a lot of these other job frameworks. Basically, it's a Lambda expression. We extract which workflow you're invoking out of there and extract the method and extract the arguments, serialize them, serialize the result, do all of that for you. So here it just looks like you're making an invocation, but that's actually a remote invocation to start a workflow. And starting a workflow returns a handle but we have a shortcut called execute workflow that essentially returns the result. So you don't have to have the low level returning a handle. But you can see with that handle, we can make those interaction calls. Here's a call to signal the workflow. This could be made from some other ASP.NET call or some other CLI, it doesn't matter. Same type of deal with canceling. This actually cancels the workflow. And cancel, unlike terminate, is like a request to cancel. It essentially sets that cancellation token because we spend a lot of time making sure that we fit into the language ecosystem. So we work with, it's a durable cancellation token, if you will. If you cancel it anywhere, it will be received by the workflow, and you can do whatever you want. You can catch that cancellation token, shield things from cancellation, however you'd like to do it. And you can obviously catch errors, anything that would be in normal code. There's also, this just demonstrates querying another interaction, and then getting the result. All that is type safe. That status for getting the result. So our workflow didn't return, or it returned purchase status here. That is type safe all the way back to the client. And we, of course, serialize that in both directions. And if you were to look at the UI, you would see it in there. You would see the arguments and the results. You would see every step of the workflow, when it's the sleep that was in there, the activity call that was in there, how long everything took. And we even have ways to hook up open telemetry with this, so you can see it as a trace too, which is really nice for distributed software like that. So that's how it looks in C# in a nutshell. Is you can create an activity or workflow, create as many as you'd like. You can run a worker, and you can use a client to execute a workflow or interact with the workflow. And there's a lot of other things you can do with the client: listing workflows, creating schedules, other things that I didn't really cover in here. So like, and I mentioned some of them here. So besides the open telemetry stuff I mentioned, we have the generic ASP.NET and generic hosting support, DI. I just made a diagnostic metric support where our metrics that are emitted from Rust actually flow back through .NET. Data conversion. So since we don't run the code and you run the code, we offer full end-to-end encryption. All of those inputs and outputs can be completely encrypted on your side and decrypted on your side. Temporal does not need them to operate. And a lot of people leverage this feature. So it's nice to have to be able to use a job server that doesn't need data. We have a testing framework that also includes time skipping server. We have a replayer, so you can take an old execution history and run it against your code and literally drop a breakpoint in there and walk through the code that ran in the past. That's the value of deterministic workflows, right? So, and I know I'm kind of blowing through this presentation, so I should probably slow down on some of these challenges because they're kind of interesting. So there's 3 challenges. There's a lot of challenges to building an SDK, mainly around API design, but there's 3 challenges in particular to .NET that I wanted to call out because I think they're just kind of interesting. And so the first one is we have to integrate with that Rust core. So like I mentioned before, the SDKs are a very complex state machine, and the workers do a lot of complex work, and it is unreasonable for us to rewrite that for every language. So we built a Rust core to do this, and languages either statically link or in this case dynamically link the unmanaged DLL to do this. In our TypeScript SDK that runs on Node, there's a library in Rust called Neon that bridges that gap very nicely. It handles lifetimes. You don't have to worry about safety too much and ownership too much. And same with Python. There's this Pyo3 library that is very nicely written to write Python extensions in Rust, and we leverage it heavily, and it works awesome. I wrote that SDK too. I can answer anything about that you'd be curious about. But there wasn't a good one for .NET. There were a couple of budding ones, but they had some problems and some staleness, and we needed to do some advanced things. So basically, we had to step back and do it the old-fashioned way, which is over CFFI using pinvoke. And it's an unmanaged DLL like any other DLL. If you used a C++ library in .NET, you know the game. So what we do is I have a bunch of unsafe Rust, which is always scary, as you can imagine, as scary as writing it in C. And I expose these unsafe external calls via CFFI, and then I generate a header from that. And this and all of this is MIT licensed open source. You can go look at it all. It's very readable. And I have to handle the lifetimes of callbacks, passing strings back and forth, and keeping in mind ownership. Because as you can imagine, with .NET being a GC runtime, you have to keep things alive that may only be over in Rust, at least for long enough for the call. So you have to use some of the low-level interop calls that .NET provides. So what I do is I generate this big header. It's actually not that big. And I use the from the CLang Sharp project, I use the CLang Sharp pinvoke generator, and it basically just generates non-CLang specific, just general interop stubs, pinvoke stubs. That was the easiest way for me, so I didn't have to handwrite it, and it's the best generator from a header I could find. It works pretty well. A lot of our complex interactions back and forth to this Rust SDK are actually done over protobuf, as opposed to building these big complex structs. Yes, that does impose a slight overhead penalty, but not significant. It's not that burdensome. There are better serialization libraries for this, flat buffers or whatever, but Proto works fairly well with our API. So the Rust side already has some of the objects that are used via our API, because our server API is gRPC. And so I had to do, like, when I make callbacks, when I set function pointers as callbacks for asynchronous calls, or when I'm sending strings, or even when I'm sending structs or pointers to things, I have to use these special interop calls to make sure that I only keep the handle as live as it needs to be, or if it's owned by the .NET side but was built in the Rust side, I have to basically tell Rust to forget about it, so to not drop it, which would free it, and instead have the .NET side use like a safe handle that on dispose, then I can call the Rust side to free it. So it's all these, if you've done old school unmanaged to managed interop before, you'd be familiar with it, but it requires a very keen eye towards ownership and lifetime, because a bug here is a seg fault. It's not a nice friendly exception usually. So that was a fairly large challenge, but it wasn't that bad. And one of the benefits of doing that, at least on the Rust side, is that the next SDK that doesn't have a good Rust bridge could also leverage this C library. But it does mean that I do have to ship this C library with my NuGet package, and I have to pre-build it for all the architecture. So inside of a NuGet package, you can put unmanaged DLLs in there under the OS and architecture that they go under, and we support most of the common ones, and a few of the others I don't necessarily pre-build for, because the NuGet package, even zipped, is like 45 megs. And I'm trying not to make it much bigger. Well, a new spec is automatically zips, but it's about 45 megs. But it doesn't compile to that. When .NET Build does its job, it only takes out obviously our managed DLL and then the specific unmanaged DLL that applies to the platform. So it's not a large footprint on deployment. It just is on development. So that was also a little bit of a challenge. We had to make sure that CI ran in all these platforms, because unfortunately, I'm not writing platform independent .NET code as much as I'd love to. Now, all the high level stuff, of course, is. So the next challenge that we encountered was how to make type safe invocations. So when you're making a remote call to a known contract, you want it to be type safe. But in our case, I was looking around and trying to get inspiration from other libraries that have done this, and a lot of them have used like that Castle dynamic proxy library to essentially take an interface, dynamic proxy it so that you could. It basically uses some of the .NET Live CIL reflection services to make a live object. I could intercept the call, and then I could serialize it, and that's actually what Azure Durable Function, Durable Entity Framework does, and some of these others. And so that's how it originally looked. And you could see there where I would just reference, I would have like a ref, which would be a proxy version of the interface or the abstract class, but it required you to use an interface. And it was not very flexible. You couldn't do too much with it. And it was made clear to me, and this is my fault for not being that knowledgeable of a .NET developer when I started this, I was not that aware of Lambda expressions and that they worked in the version all the way back to what we supported. But once we realized that Lambda expressions would work here, we jumped right in and now we use them for everything. So now you can, so if you're inside a workflow and you're calling an activity, or if you're calling a workflow, or if you're doing anything like that, it uses a Lambda expression. So that Lambda there for the second snippet where you see it says say hello workflow, and then it just calls run async. We actually extract that say hello workflow. I know the workflow name and information about it from its attribute. And we take the arguments and we serialize them and we send them to the server. And then we deserialize the result on the way back based on the result type that's given to me through this AST and through reflection. So it looks like a regular Lambda, but it isn't. And .NET, if you've ever used Lambda expressions anywhere, .NET will get mad at you if you try to do too much in there. You can't do too much. Like, so some things are not supported. Like we allow queries to be property getters. But because you can access a property inside of a Lambda expression, but you can't set a property inside of a Lambda expression. So our signals that we wanted to make property setters, we couldn't make. But that's okay. It's still well worth it. And we're very happy we did this approach. It feels very natural. You get all your IntelliSense. It almost just looks like magic that you're running remote code at that point. And like I said, there's a bunch of job servers out there that do this. We're not novel in that way. This is where we are a little bit more novel. So the last challenge that we hit, and we hit this challenge in every SDK we have to write, is we need to force you to write deterministic code inside your workflow. The only way that Temporal works and resumes on other workers is because it's deterministic, because we take the same code path the second time through to resume code based on an event. So if you had a conditional based on the actual current system time, that could take a different path on the second replay through, and it would not allow us to resume your code. We actually throw errors there. We detect those situations. And so while we would have liked to sandbox .NET, we couldn't really. Back in the day, there was like app domain and code access security if you're an old school .NET person, but they did away with that when they moved to core. And so there's no real good .NET sandboxing or interpreting that we could use to make it look seamless. So we just ask users, and we'll use an analyzer to help with this. We just ask users to be deterministic. But the problem came in concurrency. All of our SDKs support concurrent coroutines. In some of our SDKs, like Go and Java, you can't hook into their asynchrony. Like in Go, you can't replace a scheduler. So we had to write wrappers for this. But in languages like TypeScript, where we could customize the promise execution, or in Python, where we could use async IO, or in .NET here, where you can write a custom task scheduler, we're able to customize asynchronous calls in order to make them deterministic. So if you did like a task factory start new and started 10 tasks, we could guarantee that those run in a certain order and that they await in a certain order. And so it looks just like concurrent code to you, but it's not. It's still coroutines that are deterministically ordered. The problem is .NET doesn't like custom task scheduling as much as they like their default task scheduler. So the default task scheduler, and those of y'all that may be familiar, so .NET has one huge thread pool, big static thread pool class, right? You can't even make custom thread pools. And the default scheduler uses that thread pool, but obviously being a normal OS orchestrated thread pool, there is no deterministicness, if you will, determinism about it. So it is possible for you to accidentally put something on that default task scheduler. In .NET, the APIs are kind of half and half on whether they default to the default task scheduler or default to the current task scheduler. So like if you use task.run, that's not allowed in a workflow because that's non-deterministic. That goes to the default scheduler. But if you use task.factory.startNew, that is deterministic because that uses the current scheduler, which is essentially an async local, if you will. Configure wait false puts it back on the default scheduler, but configure await true, which reschedules onto the current scheduler, is okay. And it's not unique to us. As your durable functions or lanes, we all have these spots in our guide that's like, here's the .NET asynchronous calls you're allowed to make, and here's the ones you're not. And .NET even has Roslyn analyzers that will get mad at you if you do what we're asking you to do. Because they'll say, oh, you should not call task factory start new and let it use the default of current scheduler. You need to specify a scheduler because we know you probably really meant the default scheduler. And if you use the current scheduler, something bad can happen. So we even have suggestions to turn that off in your editor config for the workflow. But and so in deep down inside of third-party utilities, they oftentimes don't know that they're using the default scheduler. So transitive code could accidentally call task.run. Now, while we plan on writing an analyzer, because who doesn't write an analyzer in .NET these days, right? We don't have one yet. So in the meantime, what we did is we wrote a custom event listener that hooks into the event source for all scheduling of tasks. It's actually not as underperforming as that may sound. I know that may sound scary. Oh, you're hooking into every task system-wide, but it's just the event listener, and we discard it almost right away if it doesn't pertain to us. But we can intercept when you accidentally put something on the default scheduler or you accidentally use a timer. So up until recently, .NET did not have a way to intercept task.delay or date time now or whatever. So I couldn't have, because workflows operate on their own idea of time, which is a deterministic idea of time. So if we do not allow you to ask for the current time or to use task.delay or some of the other timeout features that use system-based clocks. You have to use Temporal's durable clocks, which means that's why we have that workflow start delay or delay async instead of task.delay. However, we do have this safeguard in there, an event listener, that will throw an exception at runtime if you've accidentally scheduled something on the default thread pool or the system clock. So we plan to write an analyzer. We'll be able to catch most of these things. And as you can imagine, with .NET Analyzer, it'll plug right into your IDE, no configuration required. So those are the three real hard yet fun, and one of the reasons I work here, fun challenges about writing the .NET SDK is you have to tailor it to the language, but there's so many unique and interesting things. Yeah, like besides just getting Rust working and pinvoke working, it's very interesting to get to have what looks like regular async .NET code actually be durable. So when you await a call, that await is a durable await that can resume on another server, or figuring out the best way to do remote type safe invocation. So that's basically it. That's kind of a quick whirlwind tour from what is temporal, what does a temporal SDK, what does a temporal workflow look like? And if you've used other workflow frameworks that are like stuck in the JSON YAML world, I pity you. Come over to the better world where we write our long-running processes in code, and a lot of the big companies already are. So that's basically it. And from how you write in .NET to some of the challenges we face. And it looks like I've used right at about 30 minutes. So I will happily take questions if anybody has any.
Yeah, I have a question. What kind of testing have you done just to, I understand the challenges, but do you have unit tests within the SDK? Do you have integration tests and so forth? Have you tested performance and so forth, and any of those available?
Sure, absolutely. So in fact, I could probably just bring some of that stuff up. Let's see here. Can you still see, can you see my browser?
Yes.
Cool, I'll make it bigger. So yes, absolutely. We have a monstrous amount of integration tests, and we write our integration tests very similar to the way that the user would write their tests. We run full workflows against the full server. As any of us that have been in the industry for a long time know, the end-to-end tests, especially if you can get them running quick, have so much more value a lot of times than unit tests. Of course, we unit test individual utilities, but the integration, we have lots and lots of integration tests. So for instance, this is the full set of, even bigger. This is the full set of workflow tests. There are hundreds and hundreds in here. You can see like I'm testing like canceling workflows, canceling activities with heartbeats, all these other things. So yes, we have a monstrous suite there, and we run in CI. Well, I haven't checked it, and it might. Okay, let's see here. Here's a nightly run. Let's see which nightly run you are. So I run a little bench nightly, but we have done lots of large benches to confirm. It actually is amongst our highest performing SDKs because you have, Go is probably our highest performing and least resource utilization because it has Go routines in it and it's pretty lightweight anyway. And .NET matches that. Java is also as high performing, but it's a little bit more resource intensive because we have to use threads. They don't have coroutines until lately with virtual threads and stuff. So, but in Go, you have to do, it's not near as type safe as .NET, but TypeScript and Python are a lot slower and more resource intensive. So .NET is really our only SDK that's super type safe and very resource conscious and very fast. So here's a tiny bench I ran on like the default GitHub runner, and I get like about like 100 advanced, and I don't want to scroll down to it, but like 100 advanced workflows a second on a little local dev server. But a lot of users get into the tens of thousands to the millions, especially when you scale out the workers. Yeah, so Rick's asking, he's struggling to understand the problem itself. So default workflow engine. So it really is a very flexible solution to a very flexible set of problems. Anytime you'd ever need long-running orchestration code, this solves that problem. We have lots of, it doesn't matter if it's like Alaska Airlines booking tickets or like Disney orchestrating shows, or and those are both C# using the .NET SDK right now. It's especially common in banks, and I would probably defer to our SA and sales and marketing side to get better answer, but very common in banks. Anytime you need a process, essentially a durable process, something that can't fail, or something that if it does fail, you need to be able to handle it reasonably and scalably, but it needs to run durably. Everybody's written a gazillion of these in their past, whether they know it or not. Everybody has systems where they're writing something to a database, maybe doing something else, sending it to a message queue, maybe popping that off, doing something else. And a lot of people may be familiar with systems that do this declaratively, like a big YAML workflow spec, or if you use a conductor with JSON, or maybe you're using Orleans actors and you're sending messages back and forth. Temporal is essentially almost the same proposition as like you might be familiar with Azure Durable Functions. They actually have the same lineage. It's durable execution of your steps of a process. And every company has tons of processes that this fits in. So it's almost too flexible to say a specific use case. So how they would solve it before Temporal? It depends. They would probably, if you had, I'm trying to give a use case. Like, let's say that you were a bank and you wanted to do a money transfer or something, right? Or like, yeah, if you're Yum Brands and you want to, do an online checkout or something. A lot of times you're constantly serializing to the database each step, right? You're having to make sure you're having to constantly worry about what happens on failure of each part, right? Process death, process crash. How do you make it durable across processes? How do you concern yourself with memory or with the process otherwise dying, or an exception here or there, or how to store state back and forth to the server? So in the old days, if you weren't using a workflow framework, which there are a ton of workflow frameworks that have been around the past 20 years, if you weren't using a workflow framework, you'd probably do an upsert to the database, then try and take the user's money, then try and be idempotent with it, and then do another upsert to the database, and then potentially be able to retry that process if the work crashed halfway through, but check if you didn't accidentally already do the thing that you did, and then having to make sure that that part's idempotent before you go to the next step, and then being able to support a catch clause that rolls it back, but only rolls it back on certain types of errors. It gets pretty nasty, but almost every company has these processes that work that way. Basically, anything that's more than one step, but that can crash between two steps would have value here. That's my best sales pitch, if you will. Is there support between dependencies? Absolutely. So workflow is just regular, is for the most part just regular code. It just has to be deterministic. So you can do whatever you want. You can execute an activity, take its results, and send it to another activity. You can execute 10 activities, take the first 5 results, send them to another activity. You can execute activities in a for loop, maybe, and then have a switch clause with case statements that send it somewhere else. And maybe that is chained into a coroutine of tasks. It's very intentionally normal code. And there are child workflows, is a concept that we support. So a workflow can start another workflow and wait on its results, start 20 other workflows. It doesn't matter.
So I'm looking at Azure durable functions. You mentioned that, just getting familiar with how that's set up and everything. So why would someone pick Temporal maybe over Azure durable functions as an example?
Sure. So for one, Azure durable functions is Azure specific. But if you remove the Azure side of it, and I don't really have like a deep down competitive dive. In fact, we work with them, they work with us. We know the devs, they know us. I mean, heck, the thing it's based on, Durable Task Framework, was built by our co-founder. Temporal supports languages a little bit more natively and has a few more features that can be executed inside the workflow, coupled with the fact that, yes, it's not specific to a certain cloud. And I mean, of course, it's all MIT licensed open source, including the server. Also, I think you'll find that the code in the different languages can come across a little bit easier to read. That isn't a fair statement. We aren't as explicit in like accepting an orchestration context that then you have to invoke this or blah, blah, blah. It's a lot of the things that we do are a little bit more implicit, but otherwise you get the vast benefit of the rest of the temporal ecosystem, which is all the other very heavily used SDKs. The temporal cloud and the temporal server would probably be the largest difference. I wouldn't say there's that much difference specific to .NET. They both have a very similar value proposition.
Well, one of the things you mentioned was a different server. So you can grab it from a different server, but durable functions are serverless.
Mm-hmm.
So what does that mean in relation to when you say server? Is that physical server? Is that a virtual server? What does that mean? You can grab this on a different server.
Sure. So and I meant when I said server, I should say server side.
Okay. Okay.
As we all know, serverless is not serverless. It's just
right.
not your server.
Exactly.
And we offer similar with the temporal cloud, though it's not a functions as a service. It's still a server technically running, but you're none the wiser. So whether you're running an Azure durable function on Azure Functions serverless, or you're running a temporal workflow on temporal cloud, you're still none the wiser. It's still, but the difference, there is a difference there in the sense that you run your code. And I should have mentioned that earlier. So there is a server component to temporal, a server side component, I should say, and it stores all the events, but you run your code, which is often different than like durable functions where you would upload your code, or Lambda where you upload your code. Now, when I say you run your code, that's run on a worker. You can, and we have proof of concepts. In fact, that's the whole talk. So the principal architect of durable functions gave a talk that's on our website that about doing temporal inside of Azure Functions serverless, because it's a pretty popular approach. But otherwise, yeah, you run your own workers, and those actually run the actual code. So you could have end-to-end encryption stuff as opposed to Lambda or durable functions where you ship your code. So the server part is required, but we have a server service. So you don't have to run a server, but you are more than welcome to run a server. And a lot of companies run large clusters. Here is, I'll put a link in the chat to that video that was given about a month ago. But yes, there is a server component, a server side component. You can run it or we can run it, your choice. Or both, the code doesn't change.
Okay, thank you. We're just collecting some of these links and we'll share them on the comments afterward in our meetup group.
Yeah, in fact, I guess I'll put the more general link, which is videos are still coming out from our most recent conference, but it is pretty popular. Lots of good videos and good talks from that conference.
Okay, great.
Yeah, so end-to-end encryption, often, yes, you do avoid some of the challenges that come with compliance, but some of them are still there. So first of all, Temporal has metadata in order to execute things. So the workflow name goes up there, just not the input and output, but you can obfuscate that, that's fine. But a lot of these compliance frameworks extend all the way through everything the data touches, regardless of whether the data is end-to-end encrypted. So, but we have several compliances our cloud has passed anyways. But yes, that's why banking loves us. that's why we're so heavily used in financial sectors and other similar sectors. Is they get to end-to-end encrypt everything, and it's like verifiable end-to-end encryption. There's no in the middle, we have keys or anything. It's literally when you call a workflow to Temporal, and you can even see it in the UI, it's an opaque blob to us, and the response is an opaque blob because we don't care, we don't need it to run.
Great. Any other questions?
And I should say we have, obviously, besides community forums, we've got a public Slack that's very popular. And like I said, all this is open source. A lot of people, once they write their first couple of workflows, it just like, it changes how they think, because they start thinking, whoa, I don't have to have this really annoying step-by-step, CI system, build system, orchestration system, whatever they might be orchestrating in a more old school way in their company. So feel free to download it, try it. It's all, like I said, very, very open source.
Yeah, great. No, I can remember the challenges and not so fun many hours of debugging workflow code written from scratch way back when.
Yeah.
So transactions and all the other stuff that you
Oh
have
yeah,
to deal with.
and that's why it's so nice with Temporals, is that at least the workflow part, it's guaranteed. It'll get through it. Typical use cases. I mean, and Ryan may even know more, but I mean, there almost isn't a use case, maybe short of like very high throughput ETL. There almost isn't a use case that doesn't fit anything that's more than one step. You can see, you'll be able to see. So this is this year's replay videos. You can see the ones from a previous year. It's just nonstop companies, all the different companies. Doesn't matter if it's like Netflix or Apple or whatever. All of them using these temporal workflows to essentially do all their steps. It doesn't matter if it's like payments of some form, or just a checkout cart, or orchestrating server builds or CI, or I mean, we have users using it for background checks, airline seat reservation, almost anything you need more than one step for, it makes sense. In the future, what would I like to add? I would like to add a static analyzer. First of all, I want to catch a lot of these mistakes at compile time. Like you shouldn't be asking for the current time, like date time now inside of a workflow. That's illegal. or you shouldn't be trying to write to a file inside a workflow. That's illegal. You have to do that in an activity. So I want to write a static analyzer to prevent that. I'd like to write a source generator to make the smart client, even though it's well typed with those Lambda expressions, I can do a source generator to essentially make a fully typed client, which would be kind of neat, but it's not really that required. We're working on this. We're about to release this concept of workflow update, which is an interaction, a bidirectional interaction mechanism with the workflow, which is going to be very popular. Otherwise, I mean, it's a full featured toolkit. I mentioned it was beta, but it's only beta due to the non-technical wing of the company wanting to get feedback and such. It's full featured on par with every other language Temporal supports. Oh, there's a nice link there. Yeah, that actually is a good link. Thank you, Ryan. In the chat, there's a use case link.
And if you could also provide your slide deck, and we'll share that out.
Oh, absolutely.
As well.
Yeah, I'll see if it'll even. I will.
If you have a link, you can. I know you're part of the group. You can also add it to our comments.
Yeah, you know what? I will do that. I'm going to open it up for visibility by everybody and put that link in the chat right now. Share. Let's see. Got too many little windows. Let's share. General access. Anyone with the link. There we go. Let me back up this chat. All right, there are the slides, and I put them together purposefully, specifically for this talk, because I haven't given a lot of .NET talks, but they're about to start coming quite heavy because we're ramping up to launch GA.
Okay. And there was another question.
Oh, sorry, I turned off my chat. Give me just a second. Is the company looking for yes, we are hiring. But we're also looking for feedback. But yes, we are definitely hiring. It's a cool job. So a couple of years ago, which is fairly early in Temporal's life, we're only a few years old. I literally like about when COVID started, I went to the Hacker News who was hiring for it, and I was like, I want a dev focused company that I can write open source all day across multiple languages. And as you can imagine, this is the dream job. There's not many that fit that bill. The NuGet package. And I'll be probably making another release next week.
Okay.
All right.
Any other questions?
Looks like we're good.
All right. Well, Chad and Ryan, thank you for joining us tonight and giving us a tour of Temporal and Temporal.net and the SDK and all the work that you're doing and the challenges you ran into, which I can just imagine. Been there, done that, but many years ago. But not necessarily building a library, just more, localized for one particular client when I was a consultant. But no, this is very cool just to see the work that you've done and sharing it with us, and be very interesting to explore further for some of our folks that joined tonight and anybody else who watches the video as well.
Yeah, absolutely. And like I say there in chat, it definitely can look like a lot. And obviously I just ran through it and talked real fast, but we have lots of docs, lots of people willing to help out. There's a samples repo that I will link, and we try to make it as approachable as possible, knowing that it can be a complex subject. So good. All right.
Very cool. Again, thank you, and really appreciate it.
Yep. You'll have a good rest of y'all's evening.